Hello everybody, we're going to look at the last rule you need to know now, okay, to do anything you like with scaling triangles, and this is called the cosine rule. So it's far more complicated to prove, but I'm going to have a go now at showing you the proof of this. So as always, we're going to start with our sort of model scaling triangle, and we're just going to designate the generic angles A, B, and C, and therefore the opposing sides to those, lowercase a, b, and c. And just like all the other proofs I've done for you, we're going to start with a height there, and we're going to try to think about how we can use that height to come up with some different expressions. So in this case, what we'll do, we'll focus on the left-hand side and the right-hand side separately, but let's think about actually splitting up that side B. Let's think if we could about what an expression could be for the right-hand side of length B, and also what we could have for the left-hand side. So let's start off with the right-hand side. Well, let's just call it X. Seems like a good letter. Let's call it X, and that would mean that the left-hand side would be, well, B minus X, wouldn't it? Okay, that way the whole thing would add up to B. So from there, we're now going to think about Pythagoras. And because we have two right angle triangles and we know a formula for right angle triangles involving Pythagoras. So let's do the right hand side first. Surely that means that hypotenuse A is going to be, or A squared I should say, is going to be equal to H squared plus X squared. And we could rearrange that to get our h, couldn't we? H squared is going to be equal to a squared minus x squared. Now, on the left-hand side, we can do something very, very similar. We can say a similar sort of thing, and that is that the c squared is equal to h squared plus b minus x squared. And again, we can rearrange that to make an expression for h squared. H squared is going to be c squared minus b minus x all squared. So we have two different expressions, one for h squared on the left in green, and one for h squared on the right in blue. So of course, you can probably guess what's going to happen now. We can make those two expressions equal to each other because they're equal to the same thing. So this follows that c squared minus, well, perhaps we should expand this now. Let's expand the b minus x. So hopefully you can do this. You should know that that is b squared plus x squared minus 2bx. And that expression is going to be equal to the right-hand expression, a squared minus x squared. Let's simplify that bracket at this stage. We're going to have c squared minus b squared minus x squared, and a positive 2bx is equal to a squared minus x squared. Okay, well, what can we do at this stage? Well, you should notice that we have x minus x squareds on the left and the right, so we could just cancel them out. Imagine adding x squared to both sides. They would just disappear. So we can rewrite it with that in mind, and perhaps let's push everything to one side that is appropriate. Let's leave a c squared on the left, and on the right, we'll be left with an a squared, a positive b squared, and a negative 2bx. So this is looking good. The only problem I don't like about this is that we want an expression involving a, b, and c. We don't really want any x's involved in the question. So perhaps we should think now about how to eliminate that x variable. Now, if we take that right-hand side of the triangle, right, so this side here, let's redraw it down here. And we know we had a capital C, we had an X, and we had an A. So we could use some right angle trigonometry to help us to define a new expression for X. So doing that, we can use cosine. You remember the cosine rule, the cosine formula in right angle trigonometry, CAH. So that adjacent to the X is going to be cosine of the angle multiplied by the hypotenuse. In other words, x is equal to the hypotenuse A multiplied by the cosine of C, cosine of that angle there. So let's swap that now into that formula. So that formula will become c squared is equal to a squared plus b squared minus 2. And we're going to put the a, look, from the expression here, right? The b was already there. And we're going to have that cosine C. And of course, that is the cosine rule. c squared equals a squared plus b squared minus 2ab cosine c. Now, we can rearrange this to find an angle, or a cosine of an angle, certainly. We could change the a's and b's and c's around if we had just started with a different triangle originally, with a different organizations of a, b, and c. But this is the defined cosine rule we're going to use for the following examples.